This is Planetary Radio Live. Welcome, everyone. We are back in Southern California Public Radio's Crawford Family Forum, not far from the headquarters of the Planetary Society. I'm Matt Kaplan, the host and producer of Planetary Radio at the Society. Do we have any Martians in the audience? Martians? I have one on my tie. Okay. Do we have any future Martians in the audience? A handful. That'll do. Excellent. Ray Bradbury would be so proud of you, those of you who raised your hand. Living on Mars, though, is not going to be a picnic. You know, well, what's a picnic without ants or without oxygen? That's really what we're here to talk about tonight. You know, NASA's pretty much sticking to its goal of boots on the red planet within about 20 years. We're going to talk about how ready we are at this point to make a go of it on that brave new world. What's it going to take for humans to survive there? And what is our encampment or station or village going to look like on that planet when it happens? Is it going to be anything like the magnificent metropolises that science fiction has shown us? That is the city of Helium, visited by the intrepid Mars conqueror John Carter in the recent and vastly underrated movie of the same name. I really liked it. We are about to ask a terrific panel about just these issues, these questions, and a bunch of related ones. The first of those panelists is very well known to regular Planetary Radio listeners, to visitors of the Planetary Society website, and to her 138,000 followers on Twitter. She's now working on a book about Curiosity, the Mars Science Laboratory rover. Please welcome planetary scientist and senior editor for the Planetary Society, Emily Koala. Welcome back.
Thank you, Matt.
Did you raise your hand when I asked for Martians in the audience?
I did because of peer pressure, but I think it's actually not my intention to go to Mars. I'm happy with robots.
You don't want to let your followers down.
Exactly.
All right, so you're an expert on Martian geology. You're an expert on the robots that we've sent there. Are you ready for men and women to follow the machines?
I have mixed feelings about that because, like, as a scientist, I want the opportunity to study Mars unadulterated by all of the passengers that the filthy meat bags that humans will bring along with them. So, I don't know, how many of you out there are parents? You know about the biohazard that children represent and the amount of stuff of great varieties that they leave behind everywhere they go. Well, that's kind of like what will happen when humans go to Mars, and it'll be a lot harder to find evidence for extant life there. By the same token, I absolutely do not want to stomp on the dreams of people who imagine bounding across the Martian surface, seeing those amazing horizons, establishing a new human presence on another planet. So my feelings are strongly mixed. At the end, I'm a pragmatist. It's going to happen. People are going to go to Mars, and we will see that future unfold as it happens when it happens.
All right, we'll just try and stay very, very clean.
Good luck with that.
Yeah. Our next guest is also a geologist and much more. David Page is professor of planetary science at UCLA. He has been exploring the moon for the last 8 years as principal investigator for what's known as the Diviner instrument on the Lunar Reconnaissance Orbiter. He's also now deputy principal investigator for an instrument called RIMFAX that has been chosen to land on Mars on what we still know as the 2020 rover, because nobody's asked the Planetary Society to run a contest to name it yet. He's going to tell us more about RIMFAX a bit later. Please help me welcome David Page. I'm hoping that you'll have something to say later as well about this issue of planetary protection, which is, you know, protecting that pristine planet from us dirty meatbags, as Emily said. As a scientist, though, what's the first thing you would do on Mars?
Get in my spacesuit.
Yeah.
You're going to give me a spacesuit.
Why not?
All
what
right,
the
okay,
hell?
I'll take the spacesuit. Well, I guess I'd first say yippee and jump around a bit. But, you know, I think digging would be the thing that I would do the first, actually.
You'd have your
because-
little pickaxe on your tool belt?
Yeah, because it's the part of Mars, the subsurface of Mars is the part of Mars that we probably know the least about, and probably also, has the greatest potential for really exciting new discoveries. We've actually explored the surface, reasonably well. We've taken a lot of pictures. We kind of see, the tip of the iceberg in terms of the geology and the hydrology and all those sorts of things. But, when you look at the Earth, for instance, as you dig down, it gets really interesting. There's a lot of, minerals, there's water, and there's also a lot of living things down there. There's a giant biosphere below us, and, the key question is that also on Mars today?
So even though, you're both planetary scientists, but you're both geologists as well. It's not like if you were up there and you found a rock with a trilobite fossil, you just throw it aside and go back to looking for other stuff.
Right, but how many trilobites have you stumbled across in your years on Earth?
Only in mineral and gem stores. So
Yeah, gem stores, yeah.
All right, we're going to come back to that, and we're going to hear about rim facts a little bit later. The 2020 rover that David's going to have that instrument on is the next in line of these amazingly successful Mars explorers that have been built and operated by the Jet Propulsion Lab, 10 minutes up the freeway from here. Humphrey Price, known to his friends and coworkers as Hoppy, is JPL's Mars Program Chief Engineer. Hoppy's been part of more missions and mission formulation studies, as they are called, than we have time to talk about. But they range from the spectacularly successful Mars exploration rovers, Spirit, and the Still Trucking Opportunity, amazing success story, to interstellar missions and even solar sails. And that last mode of transportation, that's near and dear to all of us at the Planetary Society, of course, because we have our Light Sail 2, which we're hoping is going to fly next year. Please welcome Hoppy Price.
Thank you, Matt.
You bet. Thanks for joining us. Hoppy, how we're going to get to Mars, that's really a topic for a different show. But because that's something that you've worked with a lot, you've got a couple of slides I know. Maybe we can talk about those just very briefly because, getting there is half the fun, right?
Sure. So talking about living on Mars, I like that image of the city of helium on Barsoom. And realistically, the first crews who go to Mars, it's probably going to be like a crew of 4 people, hopefully an international crew that will go to Mars. And, they may land on Mars with something like this. And it's, it's bigger than the Apollo LEM, but it would be, a lander with a descent stage, an ascent stage, solar panels. And so this is what they would land on Mars with. The first mission might just be a short stay landing, and so they would go out in spacesuits. They might have something like, the lunar rover that was on Apollo 17, or if the funding would allow it, the first mission might have a habitat and a pressurized rover. That remains to be seen, but certainly. The follow-on missions to Mars would continue to build up infrastructure, and so they would have habitats, pressurized rover, exciting science equipment like drills that can dig deep under the surface.
And this next shot that we've got gives us a little bit of an idea of this is a part of that same first phase, or is
right?
This
So we'd like for the first mission to Mars to actually have 2 cargo landers with it too, if the budget and the schedule would allow for that. And so one would be a surface habitat. That's the vehicle that's on the right. And so it would be a pressure vessel, kind of like one of the space station modules, but it would be designed for being on the surface. It would be like a house on the surface of Mars. Unlike the space station, it wouldn't be zero gravity. You'd have 1/3 gravity, so you could actually cook eggs in a frying pan and do all kinds of things you can't do in the space station.
You bringing chickens with you?
and you could afford the oxygen to cook over a flame? Okay.
Right. Well, so the eggs would probably come in a little vial that you would pour out and then cook. And then the other cargo lander concept would have more food and supply, science equipment, and a pressurized rover, which would be like a minivan where you could drive around without having to be in your spacesuit. And then when you find something interesting, when geologists find something interesting, like an area that looks like it may have been a fossilized microbial mat from 3 billion years ago, you can just get in your spacesuit and go out and explore it.
The kind of rover that Mark Watney, the Martian, got to drive around.
Yeah, exactly, just like that. So I think initially the kind of living conditions will be very Spartan, but the idea is to keep doing the missions to Mars, keep adding more habitats, more science equipment, and over time build up something that's more like the base in Antarctica, where you could have more people, even people staying there permanently.
Yeah.
And later on, you're going to show a video, which I think shows more of a grander NASA vision for what a Mars base might look like after a number of missions when you've been able to build up infrastructure.
And we're going to see that station in Antarctica a little bit later as well.
Yeah.
Okay, thank you, Hoppy.
Sure.
I told our last panelist that it's her job to keep the rest of us down to earth, though not literally, I hope. Dorit Donneville directs the Biomedical Innovations Lab at the Center for Space Medicine, which is in the Baylor College of Medicine. She joins us this evening via Skype. Welcome, Dorit.
Hi. Hi, everybody.
Hey. And I hear that you have added another job title.
Oh, yeah, that's right. So we're actually very fortunate. We just finished a 20-year gig with NASA, helping them to keep astronauts healthy in space with the National Space Biomedical Research Institute. And we got a recompete of a new institute. For the moment, it's called the Translational Research Institute, and I'm interim director. Our job is to fund research, cutting-edge medical technologies that can keep those dirty meat bags healthy in space and on Mars.
It's going to be a big challenge, isn't it?
Yeah, actually, there's quite a lot of things that it takes to keep a human healthy and safe in the space environment.
With that in mind, are you ready to start punching holes in the HABs that Hoppy was just talking about?
Well, they look kind of sterile, don't they? Some of the HABs, that at least the video we're going to be seeing pretty soon. Yeah, there's a lot of human factors that you have to consider when you bring humans on such a long duration missions. I mean, unfortunately, we don't always act as predictably as computers and rovers.
What's going to be the bigger challenge? Getting humans there, healthy and happy, or keeping them in that state when they're actually on the surface?
That's a great question. I think you have to look at the entire mission. The shorter the duration, obviously, the better. And mostly, my main concern is radiation. I think, en route to Mars, for example, you're going to be exposed to a lot of galactic cosmic rays. Once you get to Mars, of course, the habitats will take care of some of the radiation exposures. But you're talking about 6 to 7 months of getting a constant dose of a low, albeit, but still constant dose of galactic cosmic rays, which, as you know, are high energy particles, and we really don't have a way of shielding right now against those. And so I am worried about a cumulative dose, as well as the complete microgravity, which we know we can deal with. Certainly on the International Space Station, 6-month missions are fine, and as long as they exercise. But it's really the radiation that I'm most worried about.
And this is just a preview. We're going to come back to all of this as the program progresses. But before we talk about how we're going to do that survival on Mars, really one of the questions that we should also pick up is, why Mars? The moon is right next door. Titan has surfing and parasailing. Hoppy, what's the big deal about the red planet?
Sure. I think from a science standpoint, Mars is really one of the more interesting planets in the solar system besides the Earth. And, even though Europa is very interesting from the possibility of having life in undersea oceans and Enceladus, Mars is more easily accessible. And even though there's some radiation, it's nothing like the radiation that we have to deal with at Europa. And also interesting is that Mars most likely was pretty Earth-like, like 3.5 billion years ago. And so there's a possibility of discovering evidence of past microbial life or some kind of fossils there. And also from just a standpoint of humans being comfortable there, it's the most likely Earth because the day is about 24 hours long.
Maybe we should go to that next slide because it has a really good list graphically of what we have in common.
Sure. So there's an atmosphere on Mars. There's clouds you can watch go by sometimes. There is wind. There are dust devils. There are volcanoes, although we think all of them are extinct. There were hot springs because the place where the Spirit rover died might have been a hot spring in the past. Whether there's some now, we don't know. They have dunes. There's canyons. We're going to find out with InSight if there are quakes on Mars. So there are many things that would be familiar, I think. it's much more familiar to somebody living there than the moon would be.
Sounds like a vacation paradise. Emily, were you razzing Hoppy?
Well, I have a couple different comments. So first of all, I would take issue with Mars being the most interesting planet in the solar system. There are lots of interesting planets in the solar system, but we're talking about Mars tonight, so I'll let that one go by. But I'm interested in your statement that Mars is a compelling place to go because it is familiar. I would almost think that that's a reason not to go, that we'd want to go to some place that was quite different in order to explore a completely different environment in the solar system that we can't explore here on Earth.
Right, but I think if we're talking about humans living there and having a base, that I think psychologically, even physiologically, there are a lot of advantages to being on a place like Mars.
And I think I want to make it clear to the audience and the people listening on Planetary Radio that this is in no way a debate about human versus robotic exploration. This evening we're talking about human exploration of Mars, which is different from robotic exploration of the solar system. Robots will help humans explore Mars. Humans have their own goals and reasons for exploring Mars and the moon and any other location, and I think it's very important to establish that.
And
I'm going to jump in and
please.
talk about Mars for humans. So in terms of the gravity, it's a third of the gravity of Earth, and we don't know yet whether that's enough to actually maintain cardiovascular health and bone and muscle. So we will definitely need to supplement with lots of exercise. The second thing is regarding the 24-hour. Well, it's not exactly 24-hour, and actually there was a study that was done that was funded by NASA that kept people at the Mars Sol, which is 24 hours. I think it's 39 minutes and some seconds, right? And actually, with some time being on that type of a circadian rhythm, you do have some psychological and fatigue effects, and so us humans adjusting to a different Sol does have its toll.
Now, did that include duplicating or simulating the Martian light cycle, day and night cycle?
Yes, that's right.
Unlike the previous, your colleagues at JPL.
Yes,
Hoppy.
who were on Mars time for several months working
Yeah.
on the
Right.
rovers. Yes, that.
And they were being studied because that was obviously a psychological challenge.
Yeah. There were some workers who put their whole family on Mars time so that they would all experience this together and be in sync. And I think some of the kids actually enjoyed it, but for the most part, people did not enjoy being on Mars time, being on Earth.
Yeah, it's very interesting. There's actually, we've done a lot of studies with sleep. So about a third of the population appears to be very resilient with regards to shifts in circadian rhythms and sleep loss. And then a third are very sensitive. I count myself as one of those. And then the third is sort of somewhere in the middle. So you do have to sort of think about who you're going to send and how they're going to adjust.
Yeah. Dorit, I got another one really that's for you, but I hope all of you will be happy to jump in on this. First of all, did everybody see The Martian? Right? I saw it 3 times. Terrific movie. And by the way, the author of The Martian, Andy Weir, says hello. He would have been here, but for some reason he decided to go to San Diego and be at Comic-Con today.
Is that where you were, Matt?
I passed by. Actually, I took the trolley to get to the train today because I live down that way, and there was one Harley Quinn on the trolley. Dorit, did you saw Mark Watney
Yeah, I love it.
growing potatoes and eating them
Yeah.
and making
Yeah.
water and oxygen? Did you buy it?
You know, he crowdsourced that book, as I understand
did,
it, and
yeah,
he had a
largely.
lot of engineers and a lot of folks from NASA helping him. So I don't know. I'm I maybe my favorite part of the movie was the part where he actually stapled his own wound. That was actually my favorite part.
How much of a challenge is it going to be when somebody needs an emergency appendectomy and there are only 4 people there, and
Yeah,
none of
so
them is an
that's-
MD?
Yeah, that's a very great question. So, all of you are geologists, and if you're on the surface of Mars, you might get hurt, and so we may have to deal with some sprained ankles and broken bones and dislocated shoulders and such. And so we do have to think about that. And and undoubtedly, the one medical officer that will be on the mission will be the one that gets hurt. So you're going to have a bunch of engineers and geologists trying to do an appendectomy. That I'm kind of worried about that.
That happened in Antarctica, right?
Yeah,
That's right.
right.
Yeah,
that,
that's
that,
right.
that was the problem. A woman who was very sick and they couldn't fly her out.
No, there was a doctor who had to do his
She.
own
She was in it.
surgery. She.
Wow. Okay, that's like Master and Commander, the guy removing the bullet from his belly. Well, this is why, unfortunately, our board member Bob Picardo is not here, because we could really use an emergency medical hologram when we go to Mars. What we saw the Martian doing in large part is known in the biz as in situ or situ resource utilization, or ISRU. A great first-generation version of this is going to be carried to Mars on the 2020 rover, and it is an experiment called MOXIE, and I've got the I had the acronym here someplace. This could be a really good trivia question for later. You can look it up now on your smartphone. But Hoppy, can you tell us a little bit about MOXIE, and I'll look up the abbreviation.
Sure. MOXIE is an instrument on the Mars 2020 rover, and actually the Mars 2020 system is being built right now at JPL. The hardware is coming together. It's in the clean room, and it's always fun watching that come together. And so what MOXIE does is it takes carbon dioxide from the atmosphere, and it pressurizes it in a storage unit, and then it takes some of that out, and it goes between some chemical reactive plates, and it uses a fair amount of energy. It has to dissipate heat, and it generates oxygen, and then it stores the oxygen. And so it's a very small-scale experiment to actually make oxygen from the Martian atmosphere, and this could be useful to make breathing oxygen for the crews, and ultimately it would be useful for cooling it down, making liquid oxygen, which would be a rocket propellant. Or you could also, if you had a source of hydrogen from water, you could also make methane out of it too, which is also a rocket propellant. So there's a lot of interesting things you can do with the Mars atmosphere, and trying to make useful products from that.
David, do you see the potential for this kind of ISRU, oxygen, water, the other things that humans need to stay alive and maybe to make it back home to put in their rockets?
Yeah, I mean, it's absolutely essential. Any quantitative analysis of the issue suggests that you really need to find resources and use them effectively on the planet to survive, let alone make it back. So certainly. And I might say that a lot of what we do in the work as planetary science is searching for resources of different types, characterizing their distribution, and we're in a sense almost like economic geologists in a sense.
I have a question about MOXIE, actually. So we're working on manufacturing oxygen from the Martian atmosphere, but astronauts on Mars are going to need water, and can't you make the oxygen by electrolyzing the water to get your hydrogen and your oxygen that you need for propulsion?
Yes, if you have a water supply, and we think that at 40 degrees north latitude there are some areas where there are huge deposits of ice that are covered with just a small amount of regolith that we could access. But on the first missions to Mars, it would be really challenging to try to get water and use it. So the Mars atmosphere is considered, well, that's an easy one because it's just there. There's carbon dioxide, you can get oxygen, you can make liquid oxygen. And it sounds easy, but if you talk to the people who are building MOXIE, they will tell you it's very challenging. So these things sound easy, but actually they are very, very hard, and there are many engineering challenges. But I think in the long run, yes, astronauts will utilize the atmosphere of Mars to make oxygen, and ultimately I think that we will be able to harvest water and create products from that.
Emily, you made me think of that great sequence of images from the Phoenix mission, where Phoenix just dug down a few inches, a few
And there was ice
centimeters.
there, yes.
Yeah, and there was this ice, that water ice, that didn't last long. It sublimated away almost immediately, but there it was, right under the surface. David, we talked about this other instrument, RIMFAX, that you are already working on, that will be on the 2020 rover. What's RIMFAX going to do, and does it possibly have the potential to play a part in what we're talking about?
Well, RIMFAX is a ground-penetrating radar experiment, and this is a new type of instrument for Mars science. We've flown radars in orbit around Mars before and seen interesting things, especially into the polar caps. But, of course, the Mars 2020 rover is going to be going to a mid-latitude site. Our interest in really both from a geologic standpoint, what can we see below the surface with this technique, and also from an environmental standpoint, what can we learn about environmental conditions below the surface? Mars turns out to be a pretty good place to do ground-penetrating radar on. We know that there's very little liquid water, at least in the near-surface areas. And on Earth, this tends to confound ground-penetrating radar. Usually you get great signals, and then you hit the water table, and it's just blacked out. Now, of course, if we see that on Mars, that would be, of course, a very exciting discovery. But from what we know, at least, we should get very good penetration into the soil. RIMFAX will hang off the back of the rover, and then as the rover traverses the terrain, will sound basically continuously as the rover drives and create essentially a ribbon of information below the rover. It's essentially kind of like giving the ground an X-ray or maybe an ultrasound. And the kind of information that you see is sort of the same way. Most people, if they saw an ultrasound, might not know exactly how to interpret it right off the bat. But with practice and with context information, like, oh, that's the baby, that's the hands, you can then interpret the data. And we have lots of experts on our team that do that.
So nothing like this has been to Mars so far?
Nothing like this has been to Mars so far. And the nice thing about it is, of course, when you're in an orbiter, you're flying over the surface very rapidly. You can't take a very detailed image. With the rover, we're just crawling over the surface very, very slowly, and then we can get lots and lots of soundings and get a very detailed image.
There have been ground-penetrating radar sent to the moon, though, and have you learned from those in preparing your Mars instruments?
Yeah, the Chinese have sent a ground-penetrating radar to the moon just recently. Unfortunately, the rover didn't go very far, and so your ability to interpret the data by just kind of like a little meandering path around the rover isn't nearly as nice as we expect to get when we really start, driving along on the surface.
Be funny if that little Chinese lunar rover, was like just half a meter away from an underground lake on the moon. It's not likely. But speaking of which, how much water is there on Mars now? Best guess, under the surface.
Oh gosh, I mean, this is why we do the exploration, right? I mean, we have a lot of reason to expect that there are certainly conditions that can support the presence of liquid water below the surface, the temperature conditions, the pressure, all that kind of stuff. It's a very good environment, analogous to that of Earth in many respects. We don't really know where the water really is. Certainly at the high latitudes, we know the near-surface area is completely frozen. There's sort of a cap of surface and subsurface ice. But, if you dug down, 100, 200, 400 meters below the surface, what we'd find is really anybody's guess.
Dorit, do you worry at all about this, finding stuff like water below the surface and making it potable, usable for humans?
Well, we've been doing that on the International Space Station for quite some time. As you know, today's drink is yesterday's coffee, right? So,
think about it.
Yeah. So we're actually quite good at it, I think, in reusing our resources. And I think that a lot of technologies have, been developed as a result of it. The CO2 issue is an interesting one. We actually have a problem right now on the International Space Station where CO2 is a little bit too high, what we think for good health. It's within limits, but astronauts do complain of headaches, and they do feel better when they get into their spacesuits and they're breathing, a richer atmosphere of oxygen. So, getting rid of CO2 is actually an important thing that we need to think about as well in the habitat.
All right, we're going to move on to something you've already heard mentioned, and it's going to pop up here. This is the most ambitious extreme environment community that humanity has so far created. What you're looking at is Mcmurdo Station in Antarctica, which is in the depth of winter right now, down there in the southern hemisphere. At times of year, nearly 800 people live in this place. It takes about $450 million a year to keep it running, to get people to it and to and from it, and to conduct the research, which is the point of having it down there. So that amount is going to seem like pocket change compared to setting up a station on Mars. We're going to watch a video. It's a NASA video that Hoppy mentioned a few minutes ago. It explores what may be the current best guess at what a station on the red planet might look like. And panelists, as this plays, I want you to comment on what we see, including any skeptical comments. Now, Dorit, she can't watch it with us, but she has viewed it before. So we're going to do a little bit of play-by-play, and Dorit, you feel free to jump in as well. It only runs about 7 minutes, and I have the feeling the discussion's going to run considerably longer than that. So let's go ahead and roll that. Everybody knows that's called the meatball, right? Seriously.
Easy, huh?
So here we are above the surface. You can see a little bit of atmosphere there in the background. And now we're going to start exploring this station, which is going to be shown to us as it already exists on Mars. That's the exploration zone. Jump in here, gentlemen, if you want.
This is not a picture of Mars, by the way.
What are we looking at?
I think it's something you buy on the internet. People make these fake terrains.
You're kidding.
And they'll
They
sell them
couldn't
to
It
even
you.
isn't an
pick
actual
real
region on
terrain?
Mars.
No, I think they sell them to you for $20. You could include it in your video game.
I am so
I'm sorry.
offended. I wonder if NASA realizes this.
It actually it doesn't look familiar. It's not one of the.
Okay, so here, but we've descended into a crater, because that's a good place to look for stuff, right? We're
Yeah,
getting
so
there.
craters are interesting if it's a new one because it's excavated some material that could be interesting.
All right, in a minute here, I promise we're going to get into some close-ups.
Also, generally, you want to land at lower elevations if you can, because it gives you more atmosphere to decelerate through. It gives you thicker atmosphere to work with once you're on the surface.
And I don't know if anybody else has heard that SpaceX may not.
Yeah, so
be
this is
sending
the thing on the
Go
right's
ahead.
actually the deep space transport that you might hear about, and the crew transferred into that lander, and so now the lander is entering the atmosphere and then landing. Didn't show you too much about the landing there.
So here is it.
Maybe on purpose.
This is landed pretty much as we see it, Hoppy.
Hoppy, how large is that thing?
It's about 10 meters in diameter, the whole lander. Right. And so there's a pressurized rover carrying Mark Watney out to the habitat, and so there's a
It's
neat
not
concept to
blaring
use a
disco
tunnel like a
music or
jetway.
ABBA.
Dorit, what was that? Give it to us again, Dorit.
It's not blaring disco music. That can't be him.
That's true, yeah.
All right, so now we're going to set off across the surface.
Like those headlights too; those are cool.
What is a fire hose?
The tunnel thing?
That little yellow.
Or is that we're following along a tube? Is that a power line?
Oh yeah, that's a power line because the power stations everything's like a kilometer apart from each other, and so you have to drive distances and you have cables to send power.
Hoppy, why is everything a kilometer apart?
I was gonna ask the same thing.
Because when you land something, you're going to kick up debris, and you don't want to damage the other things that are there. So there are things we're thinking about to have rocket engines on two sides to direct the debris in a direction where you could put things closer together in a line, but that's just one concept. And these are nuclear power supplies there.
Oh, those are nuclear, so those are
Yeah.
heat radiators, not
Yeah, they
solar
are. Those are
panels,
heat radiators, yeah. So
Ah,
each one of
okay.
those is like a 1 kilowatt power source, nuclear fission.
which is something that is actually being worked on,
It
isn't
is being developed now. They actually hope to have a test in the next year or two of
Okay.
one of those systems.
Is it plutonium-238 that they're
No,
using?
no, this is uranium-235.
This is the real thing. These are fission reactors, right?
Yeah.
Okay.
So once you start them up, you don't want to be too close to them.
Yeah, Dorit, do we want to
Yeah,
add to the radiation environment on Mars?
I'm worried about doing X-rays of wrists, and you're giving me nuclear power plants.
Now, this is interesting because I think this guy is driving much too close to that power line. Because he's going to text, he's going to send a text to somebody.
But it has one of the Tesla auto driving systems on it, so it's not going to have any problem
thank
running
you.
into the power
Yeah,
line.
that
Elon-
text is going to take 20 minutes to get to whoever. Well, it's probably somebody on Earth, right?
Elon is going to make sure it's a Tesla, isn't he? Yeah. Okay, what are we looking at now? Propellant.
Yeah, so this is making maybe liquid methane and certainly liquid oxygen.
And there's another little rover there with tanks to carry it all over to
Right.
where it's going to
So
refuel.
at this point, there's a lot of infrastructure on Mars. So there have been a number of missions to Mars to develop all of these things because you're only going to send like one of these landers every couple of years,
Okay.
to the surface.
So here we are finally reaching I don't know. Now we've probably been going there for a few years because here
Decades,
is
a couple of decades maybe to get to here.
God.
Right.
So here is a much more impressive, it said logistics module, but Mark Watney would say the HAB.
Right.
Pirate headquarters. And so we're going to go inside the HAB now, and here we are in this little airlock. And I see, Dorit, there's a lot of Martian dust on the floor there in the airlock before they go into the main area of the HAB.
It's better than lunar dust, right?
Yeah, at least it won't cut your lungs up if you breathe it, right?
Right.
But it's
exactly.
still toxic.
Yeah, I mean, I don't think you want to be bringing in a lot of dust, exactly.
All right. We've made it inside now. We're looking around the inside of the HAB.
It's actually pretty roomy looking, isn't it?
Well, does it look roomy to you, Dorit?
It looks sterile to me. Honestly, I think if you had people in there, they'd be plastered with pictures of family and dogs and scenes back on Earth.
Which is kind of like the ISS now, which is...
Yeah, a mess.
I mean, everybody... it is kind of a mess. I always wonder why somebody doesn't clean up, after themselves in the ISS. Anyway, here's the farm. Look at all the wonderful hydroponics. They're going to have plenty to eat, right, Dorit?
No. That looks a little thin to me. We're very worried about nutrition, as you know. Palatability, making sure that vitamins stay stable, that's a major problem for us. We're really quite concerned about the food supplies and being able to give palatable food for long periods of time, enough food with all the vitamins that you need to stay healthy.
What, no Amazon Prime next day delivery of one a day?
Uber Eats, right?
Yeah, okay. All right, and here we are pulling away. I think we're just about out of this. The rover is off to go do some real exploring
Off
now.
into the sunset.
Do you know how cold it gets after sunset on Mars?
That's why the Martian had to bring the radioisotope thermal generator into the cab with him
Yeah.
to keep from freezing. All right, that's the end of our video, but not the end of our discussion. What'd you guys think? Hoppy, is that sort of our best guess at the moment?
Yeah, this is the result of a lot of planning by NASA as to the kind of surface elements that we would want to put on Mars, and over time accumulate them to have basically a base on Mars that you could keep going to, and would keep building up capability.
Dorit, were you going to jump in?
I didn't see a medical facility. That is interesting. And I didn't see an exercise machine or an exercise room. That's also very important to stay healthy. Crew quarters, they do need some privacy. It looked like it was sufficiently large that you could have some privacy, but you do want to also provide people with some private space. So that's what I didn't see.
I know that on the International Space Station, there was a long period where they could only have 3 astronauts on board, and they spent virtually all of their time doing maintenance. It was only once they got up to a complement of 6 that they were able actually to start spending more of their time doing science. With a 4-person crew sent to Mars, will they actually have time to do any science there, or will it all be growing plants and dusting things and keeping the Mars dust away?
Yeah, I think that's one of the challenges of designing the systems and testing them before we send them out there, to make sure that it doesn't require so much maintenance that you can't have a lot of time spent doing valuable science. And I know people have actually done systems analysis of crews on Mars and systems, and how much time is spent doing maintenance and how many active science hours you get of crew doing things. So it's certainly something people are thinking about and trying to manage.
David, do you have students who might be young enough to be one of those first people going to Mars? And I assume they'd be able to do geology, but do you have hope that they're going to be the multi-talented Mr. Fixits and Ms. Fixits who could handle this?
We just had a UCLA graduate PhD who just joined the astronaut corps for real, so it's definitely a realizable dream, I think, for a very limited number of people. I don't know. I've had students in many, I'd say maybe in the heyday, maybe a third of all applications we got to get into grad school in a PhD program, they had a statement saying, and of course I'd like to become an astronaut. And that was very, very common. I think it's less so nowadays, but I think a lot of people would definitely go if they had the opportunity.
So if you went,
Yes.
How much of your day up there would you want to spend out in the field doing geology?
Depending how I felt. I mean, it's just like everybody else. Number one is survival and doing your part for the mission, right? That part would be, I think, in the category of fun. But the big thing about this is, of course, there's a huge crew of people back on Earth, just as with the Apollo astronauts, who are helping you think, helping you, work through problems and stuff like that. I would suspect that most of that would be sort of directed by a group of, wise people back on Earth, sort of telling the astronauts what to do, rather than the astronauts. They may see an interesting thing as the Apollo astronauts did and pick it up, but my guess is that, and the big thing I think is that what I didn't see in the video was a lot of robots, frankly, and the capabilities of humans are basically flat over time. We're not much better, smarter than people were thousands of years ago, but every decade or so we notice a big jump in what machines can do, and I suspect by the time this really happens that there'll be a lot of robots doing a lot of things for the humans, and they might in fact spend a lot of their time actually just simply controlling and exploring remote areas, maybe in the nearby area, rather than even take the risk of going off with this rover. Can you imagine if that thing got stuck?
Right.
What kind of a problem that might be? Both, I noticed they went off in pairs.
Yeah,
so
they went off in pairs for that.
That was smart, but nonetheless, let's say if one did get stuck, you were down to be one. Then your ability, to go beyond would be reduced. So, certainly the risk and the costs would be reduced, I think, tremendously by having more robots.
Right, and another, I think, place that robots have will be in exploring special regions, because I know Emily is concerned about contaminating regions on Mars. So if you landed next to one of these subsurface glaciers and you thought there might be extant microbes there because there's water, there might be energy, that you would have sterilized rovers that the astronauts would teleoperate to go and try to explore these regions, so you didn't get the meat bags and all their effluents near the special region, and then they could take samples. You could go to some neutral zone and have people come out and gather it and go take it back to a glove box and examine it and try to protect the special regions that way.
Yeah, I think as time goes on, we interact more and more with other people, with the rest of the world virtually through our computers. There are doctors performing surgeries remotely. And I think that it's important to get humans to the location in order to be able to teleoperate things in real time, which we cannot do at Mars right now. And these guys can tell you how inefficient it is to operate a mission at Mars when you have to plan the entire day's activities the day before and make sure that the rover's not going to get into a situation that'll kill itself. If you're actually on Mars, you can actually teleoperate the rover, take advantage of the human brain in order to perform those functions. We could explore Venus or Titan that way, just by being in orbit and teleoperating robots. It would be awesome.
I want to go back to the question about who's going to go and the young graduate student and actually age is an issue that we're thinking about in terms of who to send. You want to send people that are healthy, but you also want to send people who are experienced and mature. And so the concern that we have with ISS probably going away at some point, 2028 most likely, the time that we have to train all these people and give them enough opportunities to spend time in space, there's nothing like that. And so, right now there are fewer and fewer opportunities. So I'm really worried about this young crop of wonderful men and women having enough time to become seasoned in order to be able to be picked to go to a mission like this.
Now, of course, NASA is talking about this cislunar station, which might provide that kind of training opportunity, but that's far from a sure thing so far. David?
Have people looked into sending very small people to Mars? I'm actually very
the
serious
smaller
about
the better,
this.
right?
Yeah, you'll use less
Yeah.
oxygen, you'll eat
Yes.
less food. There might be huge advantages to actually selecting the first crop of Martians, literally just based on size.
If you meet enough astronauts, they tend to be small people like me, because there isn't a whole lot of room. There certainly wasn't in the early capsules. Other than small people, Dorit, I've heard some talk about sending older people who maybe are done having children. And this,
Yeah.
of course, gets into the radiation that they're going to have to deal
Yeah,
with.
the radiation, the biggest concern we have is actually the gonads, forgive me for using a medical term. The gonads actually are most sensitive to the radiation. And, some of the cancers that we're worried about in women in particular, it's the reproductive organs, the breast, et cetera. And so, yeah, people who are older and no longer going to have children are probably going to be safer in that way. And it sounds really bad, but NASA's also worried about lifetime risk of developing cancer. So if you're an older person and you're going to die before you develop the cancer, that might be a good thing. If you're a younger person, you have that much longer to develop the cancer that you would get from the radiation. But NASA's really banking on cancer research. You're making some serious progress by the time we're worried about these things, and being able to cure any kind of cancers that we might get as a result of going to Mars.
Well, that'd be a nice spin-off from space technology, wouldn't it?
Yeah, so
Yeah.
I have a question. I mean, what is the current estimate as to how much one's chances of getting cancer would be on going to a mission to Mars?
Yeah, so it's that, I don't know if you know this, but there's been a set limit of, I think it's increase of 3% over lifetime of developing cancer. Dying from developing cancer is the limit. And I think the predictions I've seen, and again, these predictions are based on models that are, as you know, have their own limitations, as high as 6% or higher. So it's we're well above, and women in particular are more sensitive because of the risk to the reproductive organs.
Well, that's hardly
But,
fair.
but even if you don't go to Mars, I mean, your odds of getting cancer is something like 25%, aren't they? They're pretty high.
Yeah, but if you think about it, the mission to Mars and the radiation exposure does make you more susceptible. Not to mention all of the other things that are exacerbated by radiation, like cardiovascular disease. So right now, they don't send anybody up that has they don't accept anybody into the core that has some calcium in their arteries, which suggests that there's, the start of coronary artery disease. If you have a calcium score above 0, you're not going to be in the astronaut corps. But they have some astronauts who have been in the corps for a very long time who have quite high calcium scores, and they go up because they're very, they're very trained, their skills are needed, etc. I don't think those folks would be good candidates to go to Mars.
Emily?
I think that, a lot of people who would be willing to be astronauts to go to Mars would also be willing to accept a much higher cancer risk than that. And I'm
Sure.
wondering how you balance that. I remember reading Kim Stanley Robinson's Red Mars book, and he talked at the very opening of it about how the people who would choose to go on a one-way trip to Mars are maybe not quite the same mentally as the people who choose to stay on Earth. So how, as the medical officer, do you deal with the astronauts' desires to take more risks?
Yeah, so it has to actually be at the agency level, and Charlie Bolden actually had sent a letter saying that we will be looking at accepting a higher risk.
That's Charlie
So
Bolden, the former NASA administrator.
the former NASA administrator, exactly. And so this is something that NASA's looking at in terms of ethics. And, as government employees, we have to protect them, and so we really do have to do the best we can for them. But you're right. I mean, these are folks who are explorers. They are going to take a greater risk. And you'll ask any of them, and they will absolutely sign on the dotted line and go. Absolutely. But you still have to protect them as much as we can.
Although anybody who's talking about a one-way trip, that's definitely evidence of a mental aberration, in my opinion. David?
I don't know. I mean, I wouldn't mind spending my declining years on Mars. I mean,
Okay.
my family probably would disagree, or maybe they might agree. I don't know. But depending how things go, I mean, that would be an interesting way to spend your time, I think.
Were you going to jump in with something else? It looked like you...
Oh, yeah. I mean, just, the cancer risk. I mean, imagine your spouse sitting on the rocket strapped in, with this, tons of explosives below this. The cancer is just not going to be the thing going through your mind, I think, when they're launching, okay?
Dorit, what about eyesight? Because we have in recent
Yeah.
years learned, right, at least in microgravity, in 0G,
Yeah.
there's a problem.
Yeah, so the concern is not so much the eyesight, which does change with the change of the architecture of, or at least the shape of the globe of the eye. We can fix that with glasses. The concern really is the swelling of the optic nerve, which we think may be going on because of the fluid shifts up towards the head. So in the absence of gravity, a lot of the fluids that would normally be down in the lower extremities are shifted upwards. You see that with astronauts. If you look at their photos in space or their images, they have this fat face. And we think that there probably some kind of compression that's happening in the back of the eye. Mars having a third gravity, I don't know if that's going to have as much of an effect as having the zero gravity, or the microgravity near zero. And so it's not clear to me whether the third gravity would create as big of a problem, but we are concerned about it. We're trying to understand what's causing it. It looks like there may be an increase in intracranial pressure. And some of the astronauts that came back with the swelling of the optic nerve, when they tested for the pressure on the brain, it appears to be elevated even after flight when they came back. So we don't really know what's going on in space flight. Elevated pressure obviously is not a good thing, but in space all kinds of adaptations occur. Some of them are maladaptive and some of them are actually good adaptations.
Yeah, I actually have a related question, Dorit. People think about colonizing Mars, and to me that means that you're going to have babies on Mars and you're going to raise them to adulthood. I mean, what do you think the prospects are for being able to successfully raise a human in 1/3 gravity?
There was just a movie about that.
Yeah, there was just a movie about that. That's right.
Well, so one issue is could they ever come back? And I can see that they couldn't come back. But just imagine they're going to stay on Mars forever. Even if you're not bringing them back to Earth, do you think that humans could successfully develop and live there?
So I actually studied embryology, mammalian embryology, in my postdoctoral work and my graduate work. And frankly, I think gravity is going to be very important for establishing polarity and how the embryo develops. And at least that's known from other organisms, lower organisms like frogs and insects, etc. I would be quite worried about a mammalian organism like a human developing, certainly in microgravity and zero gravity, but a third gravity, I would be worried, definitely worried about the development of the embryo. I think there would be an effect, definitely.
Do you accept Hoppy's point that someone born on Mars, or maybe even just somebody who's been there for some number of years, is never coming back to Earth? Would not be able to survive in our 1G gravity field?
I actually think they probably could. So the concern would be is orthostatic intolerance. So as the fluids get pulled, if your body gets used to a 3rd G, right, and you come back to a 1G environment, the fluids would get pulled down into the feet, right? And so what would happen is that you would probably lose consciousness. They see that in the astronauts sometimes when they come back from being in zero gravity for a long period of time. If they don't fluid and salt load beforehand, they actually can pass out. And so, but we can have exercise programs where they make sure that their hearts become larger. That's the other thing is the heart is a muscle. So if you're not having to work against gravity, as large of a force of gravity all the time, then that muscle becomes smaller. So it may not be able to pump enough blood up to the head in order to keep you, conscious. And so making sure that they exercise very, very efficiently before coming back to Earth would be important. Bones would probably be weaker. Gravity is actually very, very important to keep our bones and muscles healthy. And so I would imagine that there would be muscle weakness, there could be tendon weaknesses, there could be bone weaknesses. They'd probably be much more susceptible for fractures. That's something we worry about in the astronauts as well when they spend time in microgravity.
Another reason why when you come back from the ISS, the Russians give you those comfy chairs just right out in the field where the Soyuz capsule has come down. We could continue with this topic of can humans survive up there? What are the challenges? But I want to go back to planetary protection before we run out of time. And Emily, your point of maybe we should consider very carefully before we put those dirty meat bags on the planet and what our robots can do. There has also been talk of let's put the humans on Phobos, the bigger of the two moons, and let them run the robots from there. Is that because you'd be able to do it without any delay?
Yeah, there would definitely be an advantage to doing that, and I think another reason is because it's easier to get to Mars orbit and back than it is to get to Mars orbit and land and come back up to Mars orbit and come back. So the idea is that it might be a more near-term prospect of having people on Phobos teleoperating things on Mars.
Hoppy, I'm wondering, given the fact that we've never landed anything on the surface of Mars and brought it back, are we prepared to be talking about humans landing and coming back? Is a sample return type mission necessary before we can send humans, or do we not need that precursor and can go straight to sending humans to the surface?
So there is a lot of debate and disagreement on that very subject. My personal opinion is that the problem of taking off from the surface and coming back is very analyzable, and that's something that we could actually test on Earth. You know, the entry, descent, and landing is the more difficult part, and so I would certainly want to test that before sending the crew vehicle there.
David.
I want to amplify what Emily's sort of getting at here is, you know, how premature would it be to really consider sending humans to Mars, sort of, let's say, in the 2020s or even the 2030s. We're about to come upon the 50th anniversary of the Space Treaty, which was put, in fact, I think it was 1967 when it was ratified. And this is something that's been signed on to by, you know, all the countries except maybe just a couple little holdouts, but the U.S., of course, and the major spacefaring nations are part of it. And there's this concept of preventing harmful contamination of planetary bodies as you know, a key part of it. You know, one could seriously wonder, sending humans to Mars, if that would in fact be considered to be harmful planetary contamination. This was something that was championed by the one of the founders of, you know, the Planetary Society, Carl Sagan, and this was also back in a very different era. You know, in the 1960s, they were telling us we'd have flying cars when we grew up, and, you know, we'd be living on the moon, and, you know, all this stuff that, you know, hasn't happened for a variety of different reasons. I think they envisioned maybe by now we would have 64 missions to the surface and 30 orbiters on Mars, and we'd really have thoroughly studied it. And the idea of this, you know, just general plan was that, you know, the concept of planetary protection has two sides to it. There's the scientific part, which is that we want to study Mars in its pristine state, look for evidence of life or its precursors without the contamination of Earth, you know, biota there. And that's the other side of it is more of an ethical argument that, you know, if there is indigenous life on Mars, we want to somehow, you know, protect that and just protect the planet from messing it up because, you know, well, you can argue there's lots of interesting places in the solar system. There's definitely only one Mars. And, you know, we don't want to mess that up for our, you know, for future Earthlings in a sense. So those are two aspects of it. But I think the main point is that, you know, we really are still at the very early stages of studying Mars, where every mission we learn something amazingly new about the planet. And, you know, we ought to have a pretty good idea what we're getting into before we send people.
And to me, one of the advantages of Mars sample return is if you bring back a surface sample and we're able to analyze it, we may come to the conclusion that, hey, most of these places on Mars, there's no way there's anything alive there. And so that would give you some of that information that would, you know, sort of clear the way for humans to go.
You know, the other thing we haven't discussed at all this evening is the role of private companies and their plans for Mars. And we have heard people talk about sending people to Mars independent of NASA or China or Europe or any other organization. And we don't have control over their contamination. There's some sort of verbal agreements. Oh, yes, we'll abide by the Outer Space Treaty, but who's to enforce that? And I feel a great sense of urgency to try to get some of the scientific results back from Mars before this kind of wild exploration begins to happen.
I don't know if any of you is an expert in this area, but just maybe 30 seconds. What's the current thought about how well Earth organisms, let's say E. coli or some extremophile, could survive on the Martian surface?
Well, you know, people have tried the obvious experiment, you know, create a Mars environment and see what happens. And, you know, there's sort of diminishing returns. The more extreme the environment goes, the less viable the organisms are. But the problem is that just on Earth, the environment of Mars is quite variable depending on where you go. You can go to a rainforest, there's tons of life, go to a desert, very little life, still some. The question is, what are the chances that you might actually contaminate a more hospitable part of Mars, and that's where the real concern starts.
One of the ironies, of course, is that we're making some more resistant organisms in the very locations where we're preparing our spacecraft for launch, because we work very hard at sterilizing these spacecraft, and what organisms survive but the ones that can survive all of the sterilization criteria that we apply to them. So we are sending.
I'm going to jump in as well. So
Please.
there's been a lot of experiments done on the International Space Station, and it's actually been shown that bacteria and viruses become more virulent, at least in the zero gravity situation. So, in fact, there was a company that was using the space environment as a way to create a superbug that they can make a vaccine against. So there is a concern that, or at least in the microgravity, I don't know about Mars, but there may be some changes in these microorganisms. You're right, Emily. What does survive actually may be a superbug. And the concern is the combination of that and what we see, which is reduced immune function in humans. That does concern me. You may actually have a major problem.
David, I'm going to get to you in a second, but I just have this thought of this little microscopic bug in a clean room at JPL saying, "Is that all you got? Bring it on." David.
Yeah, let's go out to a bar afterwards and write a really good science fiction story. Yeah.
We do need to move on. And to do this, our next step, we're going to give the panel a little bit of a break because we've got a special treat for you. When we come back from this, it'll be time for us to take questions from the audience here in the Crawford Family Forum, and maybe even some of you who are watching us on the live stream this evening, or whatever time of day it is where you're watching it. High on a barren volcanic mountainside on the big island of Hawaii, there are 6 men and women who are spending 8 months simulating a stay on Mars. The Hawaii Space Exploration Analog and Simulation, or HI-SEAS project, is a joint effort by NASA and the University of Hawaii. HI-SEAS 5 began January 19th of this year, so the team still has about 2 months of isolation remaining. But like Mars explorers, they aren't entirely isolated. They generously agreed to let me talk with them just a few days ago. Hello, HI-SEAS team. Very, very glad that you are able to join us for Planetary Radio Live this evening, even though we can't really have a conversation because of the half-hour or so communications delay, light speed delay, simulated at least between here and your simulated Martian landscape there. But I do have some questions for you. Before we get to that, I'm hoping that you can introduce yourselves to all of us and maybe take us on a little tour of that habitat that you've been living in for the past few months.
Hey Matt, this is the HI-SEAS 5 crew. I want to thank you and Planetary Society for this awesome opportunity.
Hi Planetary Radio, come check out where we live. This is our hab. It's in the middle of these lava fields on the slopes of Mauna Loa. Come on inside and I'll show you around. Here's our workshop and storage container. It's attached to the airlock where we suit up and decompress to go outside. Over here past the bathroom is the lab, where the crew can work on their personal research. Upstairs, we each have our own room. And here's the main area of the hab. This is where we work, eat, exercise, have crew meetings, work on projects, and relax together. And here's our coffee shop, where we can write and look out the window. So that's our home. Back to you, Matt.
That is awesome. Thank you for the great tour. Let me start throwing some questions at you now. To begin with, what is NASA hoping to learn from this mission, from your experience, that is going to help us successfully allow humans to live and work on the real Mars?
So
With our mission, High Seas is studying crew cohesion and performance under conditions similar to those experienced by astronauts on Mars. So you can see we live in a bubble, we have a 20-minute communication delay with the outside world. The eventual goal is to figure out how to send a team to Mars and have them remain a cohesive, strong team until they get back.
What other science is being conducted?
So in addition to NASA's BHP research that we do and the geology tasks we have, such as going out and exploring lava tube caves to better understand our surroundings, we also have individual projects. So for example, mine is 3D printing, so manufacturing items that we need in the HAB during the mission during increased autonomy periods.
Yeah, and I'm working with NASA's Kennedy Space Center on the Veggie payload to optimize plant growth schedules for the astronauts on board the International Space Station.
I'm using synthetic biology to adapt to mission needs, so I can make small molecules and proteins that might be useful for the mission.
What's the biggest challenge the team faces?
I think the biggest challenge for our mission is different for each person. I think when I came in here, I was expecting to have a lot of trouble dealing with staying inside all the time or having trouble dealing with being in such a small space, but I found that some of the challenges haven't actually been as bad. I don't mind being in the habitat all the time, but the communication delay that we have has been a really big challenge for me. Every communication we send out is delayed by 20 minutes in each direction, so your email to a loved one or to someone you're working with can be a really important communication that you have to get right the first time, because otherwise your response isn't going to come back for another 40 minutes at least. So you may only talk to someone a couple times a day and be trying to figure out a complicated problem with them.
I found one of the hardest things actually was struggling to solve problems, basically not being able to solve problems yourself. I think that's really hard because you don't have that communication to the outside world that you would normally have to research things for yourself and kind of find out solutions to your own problems. You have to rely on other people.
I know one of the big challenges for me is balancing work and playtime, because you have to make sure that your relationships with your crew members are strong, so you have to have enough social time, and then you're also trying to get a lot done because we have a lot of good opportunities to do science here. So finding that right balance definitely takes some time and takes some adjusting to different personalities on the crew.
Okay, what do you miss the most about living on Earth?
All right, so what do I miss the most? The crew can probably vouch for this. I talk about my puppies like they're my kids. I guess they kind of are, unrelated. But for the most part, yeah, I miss Bentley and Studebaker. Definitely back home in Denver, I guess.
I miss my little brothers and nephews the most. They are related.
I think that's the answer for a lot of us. We miss our family. I miss my husband, my parents.
Yeah, all those things. And the internet.
I also miss the internet.
I'd be surprised or possibly shocked if you told me that there has been no friction among the team members over the months you've already been there. So how do you keep the peace?
In here, everyone's really open with each other, and so anytime we have an issue, we usually address it really quickly. And that's important because the people around me here are not only my colleagues, but they're also my best friends and my roommates. And so if I'm having an issue with someone, then that means I'm going to be eating dinner alone and not have anything to do afterwards. So there's a real strong motivation there to get things sorted out really quickly, and I found the crew is all really open, and I don't think we've had many issues last longer than a couple of hours. So.
Yeah, we came into the mission kind of having an idea of what to expect from one another, right? We figured out how do we handle situations, how do we handle conflict, and we wanted to address that prior to the start of the mission. We put a lot of preparation into that because we knew that would be one of the big issues we'd have to deal with here.
And I think that's one of the important things, that we're all committed to maintaining good relationships. So you can try to bring something up in a variety of ways, and the other person is there with you trying to solve the problem.
What if NASA invited you to be part of the first genuine human mission to Mars? How many of you would start packing your bags?
I'm sure this question somewhat differs for everyone. I think also being asked the question of whether you would kind of pack your bags and go to Mars as a hypothetical, and actually being asked to do it, you may have different answers from different people. I think if you were actually asked to go and do it, the dangers and the reality of what you're going to be facing may become more apparent, and you may think about it kind of more than you would now when you're just kind of given a hypothetical. Yeah, that sounds great. Sounds like an adventure. But the reality is it would be very dangerous. And you would really have to consider where you were in your life, your loved ones and things, because there's a chance you wouldn't be coming back.
I always go back to the Gus Grissom quote of, the conquest of space is worth the risk of life. So as far as like physical harm, like that's unfortunately danger is inherently part of human spaceflight.
Absolutely.
So it is worth the risk. So I think what you guys are saying about family and affecting those around you, for me, is a much bigger factor. Because unfortunately, I do think there are some losses that go along with pushing those boundaries, but in the end, it's worth it, and it's part of finding out who we are and where we come from.
And finally, what's the first thing you're going to do when the mission ends?
I don't know about y'all, but I'm probably just going to come back in here.
You talk about it. Nice.
I really want to walk outside barefoot on grass or sand or something.
No,
Not lava.
I'll probably when I walk out of here, I'll give some hugs, but I'll probably have to call my mom, my grandma. I owe them that. That's for sure.
I think it's been really nice experiencing being part of a crew, being the few people that you have a ton of people supporting. So for me, after the mission, I'm really excited to join the industry and be one of those people helping, get those few people up and exploring. So I'm excited to get back into the industry.
Thanks again, everybody. I want to wish all of you the greatest of continued success as you finish off these last few weeks of the High Seas 5 mission. Wishing you also clear skies and aloha.
All right, Matt. Well, this is High Seas Mission 5 crew signing off. See y'all back on Earth. Holla.
All right. I want to get reactions from the panel, but Dorita, I want to start with you. We haven't yet talked about much the psychological, the sociological implications of this kind of mission.
Yeah, so I was just looking up to see when exactly you interviewed these guys, because they were really, really positive, and it sounded to me like the end was in sight.
They're 6 months in out of 8 months.
Yeah, this is why they're so upbeat. So we actually see this and actually there's been a lot of work done by people who study explorers and on long duration, very difficult types of missions in Antarctica and space, etc. And there is an effect in the third quarter where people get very, very, very depressed. They're past the halfway point. They don't see the end. And that's really a time that's quite precarious in terms of behavioral health. The last quarter, everybody's excited. They're ready to go home. They're getting in better shape. It's actually a known psychological phenomena. So we definitely see that third quarter effect in behavioral measures. So that explains a lot of the enthusiasm you hear.
This explains why the third quarter that I spend of my time on the treadmill is exactly the same way.
Yep. Yeah. So, people don't understand and don't really realize the implications of being locked up in a tin can. And there was another Mars simulation study, the Mars 500 study that the Russians put on. I think it was 2011, and we actually participated on behalf of the United States. So we had a simulation. The Russians had 6 guys, and it was an international crew. They underwent selection just like they would for astronauts. And we saw some very worrisome things in terms of behavioral health. For one thing, circadian rhythms were really messed up. So 4 out of the 6 crew ended up being very shifted in their circadian rhythms so that they weren't even able to work at the same time that the rest of the crew. So, crew would be sleeping when the other ones are awake, etc. So talk about loss of cohesiveness in the crew. The other thing that we found is there was what we call a behavioral torpor, which is something something you see in evolution in birds in particular, where they undergo a hibernation almost. They stop moving around so much. So in this phenomena, what we saw is a decrease in activity overall. So they still exercised as prescribed, but they just didn't move around as much as the mission proceeded. And so that concerns us as well. It usually goes along with behavioral metrics that you become more depressed. So, and you can test, you can predict as much as you can, but you really don't know how somebody's going to behave on a long duration when they're not feeling well. These guys aren't, they have normal gravity. They're not being exposed to radiation. We're probably not going to be worried about intracranial pressure in these guys. I'm talking about the ones on high seas in Hawaii. So they're feeling pretty well. They have access to medications if they're feeling sick. That's the other thing is medications. They have a shelf life, and some of the medications actually can become toxic. And so we actually don't know that antibiotics are going to work. All of them are going to work the entire time the crew's there. So if you have an infection, you may not be able to cure it. Or, if you have a headache, that medication may not work as well.
And I suspect that if somebody needed to have their appendix removed, they'd probably violate the simulation and pull them out. I've got to stop you because we're running a little bit late, and I want to see if any of the other panelists have any reaction to what you just saw.
I do want to remark on the high seas crew's painful lack of diversity, and I say this in a full recognition of the fact that I'm sitting here on a panel that is also painfully lacking in diversity compared to the city of Los Angeles. One of the things that I think is a very high priority for us before we send humans to another planet is to make sure that all humans are going to be able to participate in the exploration of other planets and make sure that we don't reproduce the kinds of inequalities that we have here.
Hear, hear. David, Hoppy, anything to add?
I think that there would probably need to be some significant screening of the crews, because I think that there are physiological aspects of going to Mars. I think some people are more susceptible to physiological damage, and some people are going to do better psychologically. And so I think it would probably be important that we have a number of crew that are being trained, and maybe because of the volume of crews, maybe that would need to be in low Earth orbit, because you could have commercial crews go up more frequently than people on the Orion going to the moon, to the Deep Space Gateway. But it seems like you'd want to have a pretty good cadre of people where you really understood how are they going to behave, and really screen out the ones, at least for the first few missions, that you thought were really going to have the best chance of doing well.
And David, before you close out this section, just want to say that right after this, moments away, is that opportunity for those of you in the audience to throw your questions at our terrific panel.
I think the other point is that historically the process of exploration and colonization is fraught with failure. I mean, I can tell you firsthand, not everything works out as you might expect, and so it's an interesting sort of duality between being bold and trying a bunch of different things, and then recognizing that a certain fraction of these expeditions or colonization efforts simply won't be successful, and we have to accept that if we're going to go do this. It's not going to be a sure thing.
A very wise man once said, "Our business is risk." That was Captain James T. Kirk of the Enterprise. Okay.
He made it every time, though.
It is time for us to start taking questions from the audience, and I don't know, we probably need to bring up the house lights. We got somebody way in the back there to begin us. And sir, give us your name and what is your question?
Sure, Michael, sorry. And my question is probably mostly for Dorit and Emily, but obviously it's open to the whole panel. I'm curious because you talked about a lot of the biological issues that astronauts face, and then obviously the implementation of robots as a kind of an auxiliary outside force. But is there a lot of discussion about either more ham-fisted methods of doing hormone manipulation or anything crazy like that to for mood adjustment or things like that? Or are you guys not exploring that at all? And also on the extreme end, are you talking about things like using nanobots or developing those kinds of technologies to further astronauts' abilities to travel long distances and nutrient delivery or whatever you need to do?
Nanobots, the minuscule, the microscopic robots that swim around in our bloodstream. and hopefully don't do more damage than good. Dorit?
Yeah, that's a great question. So it's not just about surviving, it's about performing well, right? You want to actually enhance performance. So we're actually looking at this question, and the concern we have is that what may work here on Earth may work differently in space because of the changes that occur. So, a drug that you give here to enhance performance, a nanobot or whatever, with the physiological changes that occur in space, both to the whatever organism you have it in, like the human, or if you're using a bacteria that's modified, etc., it may undergo some changes. So you're introducing another risk altogether. In general, we're really trying to select people who are healthy and resilient, understand what keeps people resilient, give them nutrients and exercise and behavioral countermeasures to keep themselves as healthy as possible. But I think we're going to tend to be very conservative when it comes to enhancing performance. That's a long ways in the future.
Anybody else want to respond to that question? Or we'll move on. And we'll try and keep these responses very brief and the questions as well. Sir, it looks like you're next. What's your name? Hang on here. He's coming up in a moment. Hi there. Try again. Oh, still no. We're going to run up with the other microphone here. It's very good to have redundant systems, whether you're in space or on the surface. Yes.
Yes. Hi, my name is Danny. It seems like there's a lot of tension to this discussion between the desire to explore and reach out and all of the various risks. I'm wondering if NASA or any public or sort of publicly accountable organization is simply too timid to ever really be able to get humans to Mars. Is it going to be the private entrepreneurs testing the limits who will actually get there first, even if a lot of people suffer in the process?
Wow, great question. And this was addressed years and years ago by Robert Heinlein with the man who sold the moon, where he basically concluded, nope, this isn't going to happen from government. It's going to be private enterprise. Emily?
My answer to this one is a little dark. I do think that it's likely that some private agencies or private organizations are going to try, and the most likely outcome of that is that the astronauts will die. They will either die on the way or they will die by splatting onto the surface of Mars. And so it's sort of interesting to contemplate what the future of human exploration of Mars will be after that kind of event happens.
Anybody else?
I think NASA is pretty conservative when it comes to crew safety, but there's a methodical process involved, and so once you decide you're going to do something, you build a vehicle, you test it, and when it's time to go, if you've met the criteria, there really isn't any timidity about sending the crew. You just need to be careful about what you do and test everything to the criteria that you've defined.
But let's be honest, we really don't have the budget to get humans there and to land. I mean, even right now, as you know, the contemplation is for a flyby. Having the technology to actually land and have people there, we just don't have that in our budget right now.
And sadly, someone who agrees with you apparently is Bill Gerstenmaier, who is the head of this area of NASA.
That's right.
And hopefully that was really just an attempt to tell Congress, hey, can you help us get on this? Let's go. We're going to try and get at least a couple more questions because, of course, we have What's Up coming up. And we are KPCC, SCPR folks. I hope it's okay for us to run a few minutes late. 5:10 over. Thank you very much. Where are we going next? Way in the back there. Hi.
Hi, my name is Margaret. My question is, when you have organisms in such close proximity, do you have concerns about increased virility of microorganisms because they don't have to worry about, they can mutate without worrying about having another host?
I think you're talking about the virulence. That's
Yes.
actually been shown. And I think it's not so much that they have less competition. It's a stress environment, so only things that adapt survive, right? So they have to become more stronger, adapt, and more virulent. And it's been shown in a variety of different strains of bacteria as well as viruses. So yeah, there is that phenomena.
Okay, we're going to go on. Let's try and take two more. Hi there.
Hi. You've been talking about the dangers of contaminants, and it sounds like you're talking about organic contaminants. What about our own pollution that we seem to be affecting the universe with the junk and the nuclear power on Mars, and isn't that kind of polluting and dangerous?
Hoppy, how are we going to keep from...
So if we have nuclear fission reactors on Mars, they will be confined to a certain area, and you know, when those units have finished working, you know, they'll be in one place, and that's just an area where it's designated as the death yard for the nuclear reactors. You know.
Yeah, I mean, you know, it's impossible not to pollute, as you're sort of implying. I think, though, this is an opportunity for science, though, because just as on Earth, we have a whole cadre of environmental scientists who basically study the effects of, you know, human habitation on the planet. We'll do the same on Mars. There will be huge amounts of environmental impact statements and people studying exactly what these impacts are and hopefully, you know, handling them responsibly. So it definitely will be looked at.
Dave, can you remember which is the lunar mission that it crashed on the moon and created dust that was observed by other missions for a long period of time afterwards? Or did they all do that?
I think it's the outgassing of the chemicals on the spacecraft that actually populates the lunar atmosphere, not the crashing of the dust. But yeah, we can't explore without having impacts.
Our last question is coming from... Hi there.
Hi. I just was curious, actually, for Dorit. You mentioned, obviously, some of the negative physiological impacts, such as the elevated pressure and things. I'm just curious, you mentioned that there were also some positive impacts, and I just was wondering what those were. If you could give an example or two.
The health benefits of living on Mars.
You know, it's very interesting. You don't snore, apparently, like your airways, you know, or everything's easier. And being a
Can
woman
we send
of
my husband to Mars?
being a woman of a certain age, you know, you wouldn't have to wear a bra.
Does low G have any benefit on hair growth?
Study that. I just know that there are a handful of astronauts who have said, you know, they felt great in space. There are those who felt bad and those who felt great. Maybe it's just being away from the humdrum life of, you know, having to deal with a mortgage and the wife and the kids, or the husband and the kids in some cases. Positive effects of being in space. Well, you know, looking at the Earth and enjoying the view and understanding how small we are.
That's it for this section, but I do want to give each of you, let's say 30 seconds, 35 seconds to wrap up. If you have any final thoughts. Dorit, you're at that end, so let's start with you.
Oh, wow. Can you come back to me?
I can start.
All right, we'll start at this end. Emily volunteers.
So I'm just going to give another plug for sending humans to explore places other than Mars, places like Venus, where it'd be very interesting to float at a level beneath the clouds and be able to see the surface of Venus at a rather comfortable temperature and pressure, for instance. And there are lots of other places in the solar system that would be fun to explore in person, and let's not forget about them.
I'll put a plug in for Mars, although I do study other bodies, and I like them all. There's something you've got to admit extremely unique about Mars. You know, it's a place where there's so many, you know, cool geologic things going on, and it's just a happening planet. And the fact that, you know, from a human perspective, like it was said earlier, there's a lot of things there that we can kind of relate to. If you like going to Arizona or the Hawaiian volcanoes, you know, Mars would just blow your mind. And so, you know, I think it's looking way into the future. It's definitely something that's going to be in our future, places that we'll go. And, you know, let's hope we do good by the planet and not screw it up. So it really lives up to its potential.
We have a chance to get it right this time. Hoppy.
You know, I think going to Mars with people will be very difficult. It'll be very challenging, but I think it's something that we have the capability to do, and I don't think that it's unaffordable within the kind of budget that NASA has, and I think it'll be the most impressive and inspiring achievement in human history. And you know, my generation had Apollo, and so, you know, I think Abigail Harrison and the Mars generation, I think it's very important for them to have something like this to to be inspiring to that generation and really to the whole world. And I think it's the kind of event that would really bring the whole world together in a positive way, as I think it did with Apollo.
Dorit, you get the last word.
Yeah, well, thank you. I've had a chance to think of something good. So for me, I have to be truthful. It's all about the health and understanding disease and the human body and physiology. And we're learning so much about adaptation to the microgravity environment and how to be resilient under conditions of adversity and how to provide health care in a very unusual setting. And I think that by setting the bar high, forgive the pun, we really are learning a lot about our own health here on Earth and our own disease processes. And so there's going to be a lot of positive outcomes, at least in my field, I believe, by going to Mars, a challenge like that.
Wow. Please help me thank these wonderful panelists, Emily Lakdawalla, David Page, Poppy Price, and Dorit Donneville. All right, folks, it's your turn to join our audience here at the Crawford Family Forum in Pasadena, California. And it is my time to call up for that thing that has been a part of Planetary Radio every week for the past 14 and a half years. This is Dr. Bruce Betts, the Director of Science and Technology for the Planetary Society, and my partner in What's Up. Please give him a hand. And I got to reach over here because we're going to have some things to throw out to the audience here. Welcome back.
Hey, good to be back.
All right. Tell us about the night sky, first of all.
Okay, we've got in the evening sky, you can see Jupiter looking super bright over in the west shortly after sunset. You got Venus dominating super bright in the early morning pre-dawn east, and Saturn up high in the south in the early evening and throughout the night.
Lovely.
All right, we move on to This Week in Space History, and it was for the week we were recording this for. This week, Apollo 15 landed on the moon, and you know what that means. First buggy on the moon.
Yeah.
Sorry, got me thinking Mars. The first lunar rover going to the surface of Mars.
Tooling around, throwing dust everywhere.
Yeah, good fun. All right, so let's have the audience help out with this one. So I'm going to count to 3, and then I want you to all say, random space fact. 1, 2, 3.
Random space fact.
Nice. First
Very
take.
nice.
Very good.
First take. So I don't know that you mentioned that the night we're recording is the 48th anniversary of Apollo 11.
I was going to, but I thought it would come up anyway.
Oh, and it did.
We're going to use it to close out the show, but please.
Okay. So I've got some Apollo 11 for you. Neil Armstrong carried a piece of wood and a piece of canvas from the 1903 Wright Flyer.
I did not know that.
To the moon.
Wow.
Wow.
And if anybody wants to read a great book, it's David McCullough's The Wright Brothers book. Absolutely fantastic book about a couple of guys who hopefully we are following in their footsteps as we make our way to Mars.
Cool. All right. We move on to the trivia contest.
And this is actually the contest that was sent out to our listeners 2 weeks ago. What was the question you asked?
All right. I asked, what other, in quotes, kind of ice forms what appear to be snow-capped peaks on top of water ice mountains on Pluto? How'd we do, man?
We did really well. We got a great response to this, I think, because so many people want that brand new Chop Shop Planetary Radio t-shirt, which I should have my daughter run up here and model it for us. I don't know, Laura, if you're brave enough, you're welcome to do that. But I still don't have my shirt. I still don't have it.
Aren't you getting suspicious that this is part of a plan?
You think they're trying to keep me out of that shirt because I'll hurt the sales if I wear it? All right. So,
well, it's a distinct possibility.
We always go to random.org to pick among the people who've answered correctly. And this time, random.org went to Chris Maka. Chris Maka in Milwaukee, Wisconsin, the home of beer. I'm not going to say great beer, but beer.
Man, hating on Milwaukee.
He said, what is it that's on those mountaintops on Pluto? Methane ice, which he adds is also a very poor choice for cocktails. Is he correct?
Yes, except possibly about the cocktail part.
Well, guess what, Chris? You've won, and that means you are going to get one of those brand new Planetary Radio t-shirts, the 3rd generation Planetary Radio t-shirt. It's available in the ChopShopStore.com website. There's a Planetary Society store at ChopShopStore.com, along with a 200-point iTelescope.net account. iTelescope is the worldwide nonprofit network of telescopes that anybody can use to take pictures of Mars if you want, or anything else in the cosmos. They'd probably prefer you not point them at the sun unless they've got a solar telescope there. And
there's more?
A cheap but effective pair of Bill Nye eclipse glasses.
Very cool, because there's
nice
an eclipse
reaction.
coming
Thank
up.
you. We always get other interesting responses from listeners, and I'll give you a few of those now, just a sampling. We had, in response to this, because it was methane, a whole lot of, how can I put it, flatulence jokes. And some of them were pretty funny, but it's a family show, so what am I going to do? From Jimmy Wallace in Decatur, Tennessee, he said, not only is there methane, frozen nitrogen and small amounts of frozen carbon monoxide?
Yes, on Pluto and possibly in these areas, but they actually identified on the mountaintops from spectral data that that's where some methane ice was freezing out. Yeah, you got all sorts of weird ices on Pluto.
Torsten Zimmer, regular listener in Germany, he said, methane ice, it sounds kind of lame. Why don't we call it crystal meth and wait for the media feedback?
Crystal meth found on Pluto. Film at 11.
Sarah Greenbaum, Columbus, Ohio. She says, for those who haven't yet, I recommend watching the Pluto flyover video released by the New Horizons team. You can see all of these neat features. It is pretty cool.
It is.
Finally, you may not know that we have a poet laureate for Planetary Radio. It's Dave Fairchild, who is in Shawnee, Kansas. And here is Dave's contribution. The Mountains of Cthulhu. I guess we should say that Cthulhu is one of these regions.
It's one of the dark regions on Pluto. Has been named Cthulhu.
Anybody know Cthulhu, Lovecraft? Okay, a few people out there. Why aren't you at Comic-Con? Here we go.
They couldn't get tickets, but, you know.
The mountains of Cthulhu are composed of water ice. To say they're hard as rocks on Earth is probably precise. And on the top is silver snow, and though I don't know how, the fact that I'm going to start over. You guys will know I'm doing a retake, but people on the radio show won't. The mountains of Cthulhu are composed of water ice. To say they're hard as rocks on Earth is probably precise. And on the top is silver snow, and though I don't know how, the fact that it is methane means that Pluto has a cow.
That's one of the theories being proposed for, yes, free-range cattle on the top of Pluto Mountains.
So one resource problem solved. If we go to Pluto, there'll be ice cream.
Yeah, that's how it works.
All right.
We'll talk later.
Do you want to, let's do the contest for people here, and then we'll give a contest out, your new question for the folks at home.
Okay, sounds good. Now, are you going to have me hurting my shoulder again?
Yes, I am, and I've got lots of shirts here, more than we're going to give away because we've got an assortment of sizes. So if you are lucky enough to have Bruce throw you a shirt because you gave a correct answer, you can exchange that if we have, among this limited inventory, the right size that you're looking for. So
maybe you should throw them this time.
That would be a big mistake.
Then you wouldn't be able to mock me for the bad throws.
True enough.
All right, so what's the process here? Raise your hand, and then...
Someone will race over with a microphone, and we'll see if you've got the right answer.
All right, we'll start with Apollo and move to Mars, and going with our theme this evening. So start with hopefully a simple one. Name the Apollo 11 crew. Last names are sufficient.
All right, remember, hands up. Don't yell it out. Here comes a microphone right here. Hi there, sir.
Hi. That would be Neil Armstrong, Buzz Aldrin, and Michael Collins.
Yes, that is correct.
And Buzz Aldrin, Michael Collins, still very much with us. So honoring them and all of the thousands of other people who made Apollo happen.
All right. The Eagle has landed. Eagle was the name of the Apollo 11 lunar module. What was the name of Apollo 11's command module?
Don't yell it out.
Columbia.
That is correct.
Nice work. Here's your shirt. Long throw for Bruce. Here we go. Ah, close enough. Close
sorry.
enough. It's like horseshoes. Okay.
And next I'll be giving away horseshoes. Here, catch.
We got time for maybe 3 more.
All right, good, because I happen to have 3 more. And this one, you got a lot of input from this evening in the guests. What is the gravity on Mars' surface as a percentage of Earth's surface gravity, say within 5%?
We're going to come up to the front here for somebody. Let's see who we've got. Right there. Yes, sir.
1/3.
That is within 5%, and what keeps getting quoted tonight? 38%. That is correct.
Easier throw. Almost
Glad you're
overshot.
tall.
Must
catch.
be low gravity in this room.
All right. Where does Mars fit in size compared to the other planets? If you say that Jupiter is first in size, where is Mars?
Out of
what rank?
9 planets?
It doesn't matter. This solar system, our solar system, that part does matter.
Size ranking. Anybody want to give it a shot?
Bring
One in the back and one in the front here. We're coming up to the front. Hi, sir.
It's 8th.
That is incorrect.
All right, we got.
My daughter guesses it's 4th.
That is incorrect.
Wow.
I think right here, she was
We're
third.
going way
Hold
down
on.
the line here.
Right over here.
Here we go. Way over on the left side of the auditorium.
7th.
Yes.
What?
7th.
That is correct.
Yeah. Give that woman a shirt. The last live Planetary Radio Space Trivia Quiz question for the evening is...
All right. With Viking 1 being the first successful Mars lander, what was the second successful Mars lander?
Trick question.
It's not a trick.
Viking 2.
That is correct.
All right, so remember, those of you who won those shirts, congratulations. If you didn't get the size you want, come up after the show and we'll see what we can do to remedy that situation. Now, tell us what the question's going to be for not next week, but 2 weeks from now. Please don't shout out any answers.
And I picked something that would be hard to happen to know, but you might. Mars's orbit is non-circular, it's elliptical. How much closer is Mars to the sun at perihelion, the closest point to the sun, than it is at aphelion, the farthest point from the sun? Go to planetary.org/radio contest.
And you have until Wednesday, August 2nd at 8 a.m. Pacific time to get us that correct answer, and maybe you'll be chosen by random.org and get your own Planetary Radio t-shirt, the new design from chopshopstore.com, along with that very cool pair of Bill Nye eclipse glasses and a 200-point eye telescope account. And we're done.
All right, everybody, go out there, look up the night sky, and think about what tie Matt will wear to the next Planetary Radio Live. Thank you, and good night.
It all depends on the topic. We're not quite done. We are not quite done. Please stick around if you can. I do want to mention that this guy, Bruce Betts, is the Director of Science and Technology for the Planetary Society once again, and he has a great new guide to eclipses at planetary.org.
I do. You can check it out at planetary.org in the blog section. You can also check out our eclipse page, planetary.org/eclipse.
Plus your random space fact videos.
That's true. Can I make one other comment? I just remembered that's relevant. We have, by the time this airs, there'll be about 1 week left to apply for our Shoemaker NEO grants. So if you're an avid amateur astronomer looking to upgrade your system to study near-Earth asteroids, go to planetary.org/NEO grants.
All right, stick around, and I will get us out of this program, which is now run quite a bit over, I want to show you something. I'm really proud of this. I'll have to move the microphone and maneuver the iPad at the same time. So, my craziest brother gave me this jacket about 2 birthdays ago. It really is a pretty cool jacket, but I'm embarrassed to wear it. I mean, where can you wear this kind of thing?
Matt, what's on your jacket?
Those are the patches for every one of the Apollo missions. We are making this show, as you heard from Bruce, on July 20th, 2017, exactly 48 years after the first humans set foot on another world. It was the greatest event in the history of space exploration. And if you ask me, it was pretty high on my list of the greatest human accomplishments ever. It was hard, it was expensive, and it was deadly. And we haven't been back to the moon in well over 4 decades. Was it worth it? You bet, I think, and for 100 good reasons. So now, why Mars? In part because it's what we humans do. As our boss at the Society, the science guy, says, we are explorers. When we cease to explore, when we lose the passion, beauty, and joy of it all, we become a bit less human. I believe somebody alive today, perhaps someone in this room or listening to us, is going to go to Mars. And whatever else that trip accomplishes, the journey will inevitably expand the meaning of our existence and our place in the universe. I just hope that I'm still here to join the celebration with you, Bruce. Thanks again to all of our great guests and the wonderful folks here at KPCC, Southern California Public Radio, who have enabled our journey this evening. And thanks also to all of you here in the Crawford Family Forum and watching or listening across this pale blue dot. I'm Matt Kaplan. I will be back with another episode of Planetary Radio next week. Good night and clear Martian skies.